Hello everyone. Let's continue talking about inverses of functions. So, as we said before, f of x denotes a function, and then f with a little -1 on top of x denotes the inverse of a function. So if we have a situation like this one right here, we should be able to tell that this is, if this is domain and this is the range, that this is a function because each value of the domain corresponds only to one value in the range. And as I said here, so this here is the domain for the f function, and this here is the range for that function. But as we already know, we obtain the inverse by making x and y values of the function change places. So what was the domain of the function becomes the range of the inverse, and what was the range of the function becomes the domain of the inverse. That's again because x and y change places. So what was x becomes y, what was y becomes x, what was domain becomes range, what was range becomes the domain. So now if we have, so this is obviously function. If this is domain, this is the range, then this is the function. So f of x, right? Now if we check from here, now if this is the domain and this is the range, we can also say, well, each of these corresponds only to one of these right here, right? So the inverse in this case is also a function, right? So if in cases like this, when we have a function and then inverse of it is also a function, we call this one-to-one. So that's why we have this one-to-one here. So this here is a situation which we call one-to-one. One-to-one. So not only that we have a function, the inverse of it is also a function, right? So each value from here corresponds to one value over here. Now if we are to graph these points, so let's first graph the green ones, the original function. So this one would be -2, 1, right? So -2, 1, 2, -2, 1 here. So that will be right here. -2, 1, right? And then next point would be 0, 5. So 0 on x and 5 on y. So 1, 2, 3, 4, 5. So that will be right here. So this is 0, 5, right? And then 4, 6, right? Ordered pair, 4, 6. So 4 on x, 1, 2, 3, 4. And then 6 on y, which is right here. So that will be somewhere around here. So this is 4, 6. Now let's graph the inverse of this function. So let's change color and let's graph these kind of backwards, right? So now the domain is 1, range is -2. So we have 1, -2. So 1 and then -2. So that will be right here. So this is 1, -2. Okay, and then we have 5, 0. So now we have 5 on x, 1, 2, 3, 4, 5 on x, it's right here. And 0 on y, right? So this is 5, 0. And then we have 6, 4. So 5, 6 on x, and then 4 on y, so that will be somewhere here. So 6, 4. Now if we take a good look at this, what do we see? Well, first of all, see how 4, 6 became 6, 4. 0, 5 became 5, 0. Negative 2, 1 became 1, negative 2. So x and y changed places, right? So not only that the green is inverse of red, the red is inverse of green also, right? But one thing that we need to see here is, see this y equals x line, the 45-degree line? That each of these points actually reflected over that line. See how 4, 6 reflected over under 90 degrees and became 6, 4. 0, 5 did the same thing, reflected over and became 5, 0, right? Also under 90 degrees. And then negative 2, 1, or let's say 1, negative 2 reflected over and became negative 2, 1. Either way, right? In either direction. And this is always what the inverses do. Inverses reflect over the y equals x line, right? Or so-called 45-degree line. So if we have the original, green in this case, it is going to reflect over y equals x and show up on the other side of that line, and that's the red values right here. Now again, if the red values are the original, then if we reflect them, we will get the green values, right? So the main points here, a function is one-to-one function if not only domain of it corresponds to, each value of the domain corresponds to one value each in the domain, but if the backwards is true, if each value of the range of the function corresponds to each value, to one value each of the domain. So if that's the case, if both function and its inverse are functions, then we have one so-called one-to-one function, right? And then the second point is that inverses reflect over y equals x, right? Or so-called 45-degree line. So if two functions are inverses of each other, they're going to reflect graphically over this 45-degree line, right? Or y equals x line. Thank you for watching. Like and subscribe.